In this video, we're going to talk about externalities and how they impact a market economy. Externalities involve costs or benefits that are either borne by or received by third parties who are not directly engaged in a transaction. So they're effects of transactions that impose costs or benefits on other people outside of that immediate transaction. These externalities could be either positive or they could be negative. Positive externalities are benefits received by people outside of the transaction, and negative externalities involve costs imposed on people who are not directly involved in the transaction. These externalities could be generated by producers as part of their production activities, or they could be generated by consumers as part of their consumption. One example of a positive externality is a vaccine. When you consume a vaccine, you're not only receiving benefits directly yourself, you're also protecting other people. And a very large share of the benefits from a vaccine are these external benefits. Education also represents a positive externality. Not all the benefits from your education go to you. Some of them go to other people. Some may go to your family members. Some may go to friends. Some may go to coworkers. If you learn new skills or if you improve your ability, your reasoning skills as part of your education, that's going to make you more productive in many areas of your life, and some of that will have an effect on other people. One example that most people do not take into account is that one of the most important determinants of the earnings of a child is a parent's education. And the reason for that is that much of what we learn, we initially learn from our families, because that's where we learn our basic language skills, some of our basic reasoning skills. When we enter the school systems, we already come in knowing a fairly large share of our vocabularies. And when you acquire a college education, some of the benefits from that will be received by your children and indirectly through any grandchildren you may have, and so forth. One other example of an externality that's not on the screen, which happens every winter here in Oswego, is snow shoveling. When you shovel the sidewalk in front of your apartment or your house, you're doing that based on your own benefits, but you're also generating a positive externality for anyone else who may happen to walk on that sidewalk. And as you'll see during the winter months in Oswego, those sidewalks are not always cleared by the residents. Another form of externality is loud music that your neighbors play that you happen to enjoy. So if people in neighboring dorm rooms or people in neighboring buildings are playing music that you really like, or if there's a concert nearby that you really enjoy, you're getting a positive externality from the decisions of the people who are choosing the music that's being played. Negative externalities are also very common. The one example that everyone talks about is pollution. Water pollution, air pollution, soil pollution, and so forth. Any type of pollution represents a side effect of some type of either productive or consumption activity. Certainly lots of factories generate pollution, but we also generate pollutions from our cars by burning leaves or by backyard barbecues. The externality here is any damage that pollution does to other people. Secondhand smoke can impose health hazards on people beyond those who are directly engaged in smoking. When individuals engage in driving while intoxicated, they put other people's lives at risk, and any damage that they do while driving while intoxicated represents an external effect of their own private decision-making. And just as loud music that you enjoy represents a positive externality, loud music that you find really annoying could be a negative externality. When someone in your dorm is playing loud music, some people might be getting positive externalities from that. Others may be getting negative externalities, particularly if they're trying to study. Whether that is a positive or negative externality depends to a large extent on the tastes and preferences of the people who are being affected. The main issue, though, as we'll see, is that the people making decisions take into account only their own costs and benefits and not the costs or benefits that are being imposed on other people. Let's talk about negative externalities in more detail. The main problem with negative externalities is that when people make decisions, they weigh their private costs and their private benefits, and they produce things where the private marginal cost equals the private marginal benefit. But the cost to society will be greater than the cost to the individuals because of the negative external cost. The problem with the negative externality is that the social marginal cost exceeds the cost to the people who are actually making decisions about the activity. When the firm is producing a good and generating pollution, they don't take into account the costs they impose on other people by that activity. The individuals making decisions set their own private marginal benefits equal to private marginal costs. And let's consider that case of pollution in a bit more detail. At a competitive equilibrium, in a market economy, the demand curve reflects the private marginal benefits of the consumers, the supply curve represents the private marginal costs of producers, and in this case we're going to assume that the externality is caused by production. So the private marginal benefits from consuming a good will be the same as the social marginal benefits. The difference, though, is that the social marginal costs are greater than the private marginal costs and therefore greater than the social marginal benefits. Because of that, we know that if the cost to society is greater than the social marginal benefit at the equilibrium level of output, we're producing too much of the activity. So the basic problem is that whenever there are negative externalities, there's going to be too much of that activity. So negative externalities result in overproduction, and I think that would apply to all the cases we've just considered. People deciding whether or not to smoke in a crowded room may not take into account the damage that their smoking may do to the health of people around them. When people engage in driving while intoxicated, they're imposing costs on people who might be injured in an accident. This diagram illustrates this a bit more carefully. We're assuming there's no externalities from consumption, so the demand curve reflects both the private marginal benefits and the social marginal benefits. But the cost to society, the social marginal cost, is equal to the private marginal cost plus the amount of external cost. So the vertical distance between the supply curve and the social marginal cost curve represents the external cost to society. The competitive equilibrium will put us at the point where private marginal cost equals private marginal benefit, which here is labeled as Q sub PC at a price of P sub PC. However, the socially optimum level of output occurs at the level of output where social marginal benefit equals social marginal cost, and that occurs at an output level of Q star. This diagram illustrates the overproduction that occurs because the people engaged in this activity are not taking into account the costs they're imposing on others. If those costs were taken into account, then the equilibrium price would be higher at P star, and the socially optimum level of output would be Q star. So let's talk about some ways in which markets can achieve this. One possible remedy is regulation, that if people are engaged in activities that are harming other people, you can regulate the activity to restrict that. In the case of pollution, you could set emissions limitations that limits the amount of pollution that can be released into the air or into the water. That's one solution. You just simply restrict output so that it will not be at the competitive equilibrium, and you try to get it to move towards the socially optimum level at Q star. Another way of doing this is using what's called a Pigovian tax. This idea was first created by an economist called Pigot. And what Pigot suggested is you can charge a tax just equal to the value of the external damage. And by doing that, you're essentially shifting the supply curve vertically upward by the amount of the tax, which would mean the people engaged in the transaction would now take into account all their costs, including the external costs, because that's equal to the value of the tax, and the market by itself would get you to the appropriate equilibrium at P star and Q star. So that's another way of dealing with this. In this case, the government doesn't have to set pollution restrictions. It just has to charge a tax on the activity equal to the value of the damage that occurs. That's one of the justifications for the very heavy taxes that are imposed on cigarettes. Another solution, which economists generally prefer, is what's known as a cap and trade solution. And with a cap and trade solution, you estimate what level of pollution would be optimal for society, and then you issue pollution permits to firms where the total amount of permits would just get you to that total level of output. And the advantage of that approach, as compared to regulation, is that with a regulation, all firms would be forced to cut back on pollution by the same amount. But the problem is the cost of reducing pollution is not the same for all firms. With a cap and trade system, the firms that are able to reduce pollution at a lower cost can choose to reduce pollution by more, and sell their permits to the firms where it's more costly to reduce pollution. And that results in a situation where you can attain the same total reduction in pollution, but in a more efficient manner by reducing pollution more in those firms where it's less costly to reduce pollution and not reducing pollution by as much in those firms where it's more costly. So you end up achieving a given pollution reduction at a lower opportunity cost to society, which allows you to more efficiently achieve any given level of pollution reduction. So now let's consider positive externalities. When a positive externality is present, the social marginal benefit is larger than the private marginal benefit. The people making decisions are generating some benefits that go to people who are not directly involved in the decision making. Individuals, though, when making their own decisions, set their own private marginal benefits equal to their private marginal cost. That's what would happen in a market economy. Let's consider, for example, the case of a vaccine. At a competitive equilibrium, individuals set the private marginal benefits equal to their private marginal cost, and we're going to assume that the cost of producing the vaccine is going to be the same for both society and for the individual firms. So we're assuming that the externality comes from the consumption of the vaccine, which I think is a pretty reasonable assumption, because the benefits are generated by individuals consuming the vaccine and protecting other people from whatever virus that vaccine is designed to combat. But the problem for society is that the social marginal benefit is greater than the social marginal cost at that competitive outcome, because while the marginal benefit is just equal to the marginal cost for the people consuming it, the benefits to society of people consuming the vaccine is substantially larger. And as a result, we know that whenever the social marginal benefit is greater than the social marginal cost at some output level, society would be better off if more is produced. So a competitive equilibrium would result in underproduction of any activity where there's positive externalities. That's why we see, for example, not everyone consuming vaccines, because they weigh their own benefits and costs without considering the benefits that they provide to other people. And similarly, it's why we don't always see an optimal amount of snow shoveling taking place in northern cities such as Oswego, New York during the winter months. We can also use a diagram to illustrate this. The demand curve reflects the private marginal benefit in this case. The supply curve represents both the private and the social marginal costs. At the competitive equilibrium, the market would produce this vaccine at a price of P sub PC and at a quantity of Q sub PC. But the benefits to society are greater than the private marginal benefits, and the social marginal benefit takes that into account. The vertical distance between the private marginal benefit or demand curve and the social marginal benefit curve represents the value of the external benefits generated by this positive externality. In the case of a vaccine, that vertical distance would represent the benefits that other people get when a given number of people are vaccinated in the population. And what we see is that the socially optimum level of vaccine consumption would be Q star, the actual level would be Q sub PC, and as a result, we have this underconsumption or underproduction of any activity or any commodity that generates a positive externality. So there's a couple of remedies that could be used for this. One is, again, regulation. In the case of vaccines, governments or schools and so forth could require that you must be vaccinated in order to enter, say, the public school system or to arrive at college. And in fact, we do this for many vaccines. Similarly, since education provides some positive externalities, the government also mandates that people stay in school for a certain number of years. In some states, that's 18, in some states, it's 16. That varies from state to state. But in all states, there's a minimum number of years of education that's required, in large part because of the positive externalities associated with everyone's consumption of educational services. Another alternative is to subsidize the activity. And just as we had Pigovian taxes, there are also Pigovian subsidies. And the goal of these is to set them just equal to the marginal external benefit, because what that will effectively do is shift the demand curve vertically upward, since essentially you're subsidizing the activity For example, if there's a $2 subsidy on a vaccine that would cost $4, that means that if you pay $4 for it, the government pays the other $2, and the price that would be received by suppliers at that quantity would be $6. Essentially what happens is the demand curve facing the sellers would shift up by the amount of the subsidy, and if that's set just equal to marginal external benefits, the new equilibrium occurs right at this socially optimal level of output. So in general, when there's externalities, markets break down, and government intervention in the form of government regulations, taxes or subsidies, or in the case of negative externalities such as pollution, perhaps a cap-and-trade system could be used to move you closer to a socially optimum level of output.